Define your schema, set up the fields, so it's your tables with schema, read the documents, and finish. There's actually a step for finishing code. And here's the first half of the code for setting it up. We include a bunch of stuff. We set up an analyzer. Remember I said the analyzer is the thing that takes the text and splits it up, makes it readable and understandable. We set up the indexer. We tell it where the file is that's going to hold this index. And we set up the fields. And now we've gotten that first section done. So in this document, we have a field named title and a field named body. We could have a lot more, or in this database, I should say. Leave the boost aside, but there's many features in Lucene. One of the things we're using here is we're saying, look, if you do a search and you find it in the body, that's worth more, or find it in the title, that's worth more than finding it in the body. Because it makes some sense that if I'm looking for Elliot, I really don't want to find Elliot Ness in some document. Yeah?
Can you say a few words about using it in other languages except English? Is it possible?
Oh, yeah. Lucene doesn't care about languages. Lucene, the analyzer can pull, as long as you get into tokens, you can do any search you want, UTF-8. And so you can use this in Hebrew, you can use it in other things. The tricky part is building the analyzer that converts it to the appropriate form. And I believe there are other versions. I know there's one for French and German. I don't know if there's one for Hebrew. I've already built one that you can just download. The second part is you already know how to parse files. So for each file, we tell the indexer, here's your document. We set the values for the title and the body, and we go. And that's it. The document is already in Lucene. So now we've got the data. Finally, that last step there, index or finish. This is sort of really important, although it seems not. Lucene has all these data structures, and it needs to stick them all together and optimize them. And that's what the finish does. So the next step, we've got our data. How do we do a search? Well, the most important thing is you got to set up the same search as you did for the index. If you don't use the analyzer correctly, you get really screwy results. And then you do the search. So here we go. This is the whole search. And half of it is set up. We import some stuff. We say the analyzer, which we already used from before. We tell it where the searcher is. Before we called it an indexer, now it's a searcher, because we're doing it the other way. We take our data and we say, okay, searcher, take my input and tell me what you can get. Here's a bunch of words that I want to search for. Give me the results. And then we use this thing called a highlighter. Remember I said I want these highlights. This is like the coolest thing. I love this. Because I can get this text that shows up and says, blah, 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 Elliot Jaffe, blah, 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 blah. I'd like to see my name in print. So the highlighter goes ahead, pulls out the text around the thing I found, and then I can just print it. And that's my search. I'm done. So I wish it was that simple. It's not quite. The example I showed you works, and it's probably good enough to get started with. If you wanted a really quick and dirty full-text search, you'd be done. If you're actually working in a business or you need something that really does more and it has a lot of features to it and you need to be careful with it, so there's more work to be done. So the first thing I want to tell you about is analyzers. Analyzers are not as trivial as we presented. What you can do is you can stick analyzers together. Think of it as a pipeline of filters in the Unix world. So for example, the first thing you do in analyzer is you take the tokens and you convert them to lowercase, or uppercase, as the case may be. So you have a canonical version of the database. You take a tokenizer, because you want to remove all the punctuation. You don't want to be searching for quotes and umlauts and commas and periods. So the tokenizer removes all that. Then you have a stemmer. In English or in Hebrew, you have the shoresh of the word. So you really want to be able to do searches on the shoresh, on the stem of the word, and not on the whole thing. So you can have a stemmer which pulls those out. If you want to be efficient about the use of your data store, you can run what's called a stopalizer, which gets rid of all the common words. Because why should I bother indexing the fact that the word A shows up 100,000 times in my document? It just is not helpful. So you get rid of those words with a stopalizer. If you do it right, it can make your system really cool. If you do it wrong, it just makes it slow and more complicated. Other things, you can do filtering in Lucene. You can set it up and say, look, when you do this search, only search titles or only search bibliographies. And that makes it more efficient and gives you nice checkboxes on your web page. You can do things like boosting. You can say, if you find it here, it's worth more than if you find it somewhere else. If you find 2 words together, that's worth more than separating by 15 words in the middle. These are important search concepts. You can do ranking. So Lucene does some amount of ranking. You can play with the rankings. You can say, look, if it shows up 16 times in the same document, that's a better hit than if it shows up 1 time. Unless it shows up in the title of that document, in which case it's probably more important. So you can play with the rankings, because at the end of the day, you get exactly what Google does, a ranked list of hits. And there's this concept of scoring, which is term frequency. How often does this term occur? How common is the word? And inverse document frequency. How frequently does it show up in the document? Which is more interesting to me. So I'm pretty much done with my talk, which is good. There are some things to look for here. If you want to look at Lucene, Lucene is an Apache project, lucene.apache.org. It has a list of all the different implementations of Lucene. I think there's about 20 of them in different languages, for different purposes. Extremely successful project. There's this, some of the data I got came from a YAPC European conference in 2006. So if you want to look at another presentation that goes a little bit more detailed, I think that was an hour-long presentation, so there's clearly more detail there. Keynote Search was at OSCon 2006, and a very long discussion of Keynote Search and why it's interesting and why the performance is better than Lucene and what they're going to do in the future. And finally, something that I felt important to raise with you. So we had to talk about structural regular expressions. There are these 3 funky regular expression tokens that you can use in regular expressions, which do before, after, backward search, other funky searches. Now, they look really cool, and when you use them, you say, hey, I'm using this really neat feature. Well, the bad news is that they're actually set global state in Perl. And they make every regular expression you run in that program run 100 times slower. Okay? Even though you only used it once, every regular expression that you run now has support for that and runs 100 times slower. So if you're ever going to use Lucene or Keynote Search or any of those guys, basically the filters, the analyzers, are just regular expression parsers. And as we all know, that works great. It's really fast in Perl, except if somewhere in your code, without your knowledge, you've used one of these backwards or forward operators, in which case it's going to run 100 times slower, and you're going to say, how come it's so damn slow? So you really need to be aware of that. And it's one of those gotchas that you would just never know unless you happen to hit the right page on the internet. So let's see, anything else to say about that's pretty much my discussion today. Hope you enjoyed, and good luck building full-text search engines.